Hi, third grade. Welcome back to week 7 math. I'm going to share the screen. So as you saw it today in Nearpod, we worked on our application problems. We have lots of tools to solve multiplication problems, right? We have arrays, we have repeated addition. And also we do have the tape diagram, which we haven't talked about, but we are going to be talking about tomorrow and this week. So it says, explore commutativity as it relates to multiplication. Which tape diagram represents the application problem? And remember, our application problem was, Jerry brings 3 water jugs to her soccer game and to share with her teammates. Each jug contains 6 liters of water. How many liters of water does Jerry bring? Okay, so if you'll think back, to when you did tape diagrams, and you can also write a multiplication sentence for this. So we figured this out, right? We drew we drew a 3 by 6 array, and you guys did awesome on that, right? So rows of 3, so 3 rows was how many in each row? 6, right? So we had kind of a big array. We drew a 3 by 6 array, and we were able to solve that because we were counting by threes, right? All right, so am I done yet? No, I'm still building my 3 by 6 array. Okay. 1, 2, nope, I only got 5. I need 6 in each row, right? To actually make my 3 by 6 array. So how many liters of water does Jerry bring? Well, we figured it out. You guys told me, right? 3 times 6, or we could count by threes, right? 3, 6, 9, 12, 15, 18, right? So our answer is 18. But what does that look like as a tape diagram? All right, I'm going to erase. Well, what does that look like as a tape diagram going forward? All right, let's check that out. Erase. Okay, so our tape diagram, right? They're giving us here. It says, which tape diagram represents the application problem and how do you know? Well, the multiplication sentences are related, right? As we talked about, we had 3, right? We have 3 times 6, which is what we figured out, right? Equals 18. And then if we flip-flopped it, it would be okay because then in multiplication, the order does not matter. Doesn't matter. We're going to get the same answer. So this is an example of the commutative property, right? We could have 6 groups, right? With 3 in each group, right? So this one would represent the application problem. But also, what does this property tell us about the product and its factors, right? It says even if the order of the factors change, right? Factor, whatever we're multiplying by is called the factor. Even if the order of the factors change, it's okay, right? The product stays the same, right? Okay. Just when we counted by threes, uh-oh, is this right? No, right? Because that's where we have to double check our work here, guys. I was wondering if you would catch that. Okay, right. So this would be, but we're still gonna get the same answer. Each one of these is gonna be 6, right? So you're counting by 6s, or you can count by threes. 3, 6, 9, 12, 15, 18, right? So the order does not matter. It just basically, they both show that the product is 18 here. So using commutativity as a strategy, we know a lot more multiplication facts than we realize that we've even practiced. Ooh. So we're gonna keep practicing this in class this week. And also make sure you're logging into your math homework and practicing skip counting, because that will really, really help with our multiplication facts. And we'll get into some more, we'll talk about how does commutativity relate to multiplication. Okay, all right. So I will see you guys in class, and good job today.